information lifecycle explains how data changes from the moment it is created until the moment it is disposed of, and understanding that progression is essential for applying the right protections at the right time.
Data is not static, even when it sits quietly in storage, because its value, sensitivity, and risk profile evolve as it is used, shared, and combined with other information.
Security problems often arise when protections are applied only at creation and then forgotten as data moves through systems and teams. A lifecycle view forces you to think about how exposure accumulates and how controls must adapt as data ages and travels. When lifecycle thinking is absent, organizations tend to overprotect some data and underprotect other data without realizing it.
Before we continue, a quick note. This audio course is a companion to the CISS books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series.
Life cycle stages typically include creation, storage, use, sharing, archival, and destruction, and each stage introduces different risks and control needs.
Creation is where data first appears, often through user input, system generation, or ingestion from external sources.
Storage is where data rests, sometimes for long periods, and storage choices affect confidentiality, integrity, and recoverability.
Use is when data is actively accessed and processed, which increases exposure because more identities and systems are involved.
Sharing extends data beyond its original context, often increasing risk through additional access paths and dependencies.
Archival preserves data for long-term reference or legal reasons, while destruction removes data when it is no longer needed. Treating these stages distinctly helps ensure that controls remain appropriate rather than assumed. Data classification is the process of assigning sensitivity levels based on the impact of unauthorized disclosure, and it provides a structured way to prioritize protection. Not all data deserves the same level of security, and classification prevents the waste and friction that come from treating everything as maximally sensitive. Impact-based classification asks what would happen if data were exposed to unauthorized parties, focusing on real consequences rather than abstract labels. This approach supports rational decision-making because it ties protection to harm rather than to convenience or tradition. When classification is clear, teams can apply controls consistently without debating the importance of each individual dataset. Classification also considers integrity needs and availability requirements because disclosure is not the only way data can cause harm. Some data must be accurate and trustworthy to support decisions, financial reporting, or safety-related processes, making integrity a primary concern. Other data must be available when needed to support operations, customer service, or regulatory obligations, making availability critical. A classification scheme that considers only confidentiality misses these dimensions and can lead to misplaced priorities. By incorporating integrity and availability, classification reflects the full range of security goals rather than a single axis. This broader view improves alignment between data protection and operational reality. Many organizations define data categories such as public, internal, confidential, and restricted to simplify classification decisions. Public data is intended for open distribution and carries minimal harm if disclosed. Internal data is not meant for public release, but typically poses limited harm if exposed. Confidential data involves meaningful harm if disclosed, such as personal information, financial records, or proprietary material. Restricted data represents the highest sensitivity where disclosure, alteration, or loss could cause severe harm to individuals or the organization. These categories provide a common language that helps non-specialists classify data appropriately without deep legal or technical analysis. Classification criteria should be grounded in harm types, such as financial loss, legal exposure, reputational damage, or safety impact, to ensure consistency and defensibility. Financial loss includes direct theft, fraud, or competitive disadvantage. Legal exposure includes regulatory penalties, contractual breach, or litigation risk. Reputational damage affects trust, customer relationships, and long-term brand value. Safety impact applies when data supports systems that influence physical processes or human well-being. Using harm-based criteria reduces subjectivity and helps resolve disagreements by focusing on consequence rather than opinion. It also supports communication with leadership because harm categories align naturally with business concerns. Handling rules attach to classification levels and define how data must be accessed, stored, transmitted, and shared. These rules translate abstract sensitivity labels into concrete behavior and technical requirements. Access rules define who may view or modify data and under what conditions. Storage rules specify where data may reside and what protections must be applied at rest. Transmission rules govern how data moves between systems or parties, including encryption and approved channels. Sharing rules define when data may be provided to third parties and what approvals are required. Without handling rules, classification remains theoretical and fails to influence day-to-day decisions. Reclassification is necessary because data value, context, and regulatory obligations change over time, and static labels quickly become inaccurate. Data that was once highly sensitive may become less critical after a transaction completes or a contract expires. Conversely, data may become more sensitive when aggregated, linked to identities, or repurposed for new uses. Regulatory changes can also alter classification requirements by redefining what constitutes protected information. Reclassification ensures that protections evolve with reality rather than lagging behind it. Programs that ignore reclassification often accumulate unnecessary restrictions or miss emerging risks. Labeling supports consistent handling across systems, teams, and third parties by making classification visible and actionable. Labels can be applied through document headers, system attributes, or data management tools, depending on environment. Visibility matters because people cannot follow handling rules if they do not know how data is classified. Consistent labeling also supports automation, enabling systems to enforce controls based on classification rather than relying on manual judgment. When data moves between teams or organizations, labels help preserve context that might otherwise be lost. Effective labeling reduces error and improves compliance without constant training reminders.
Metadata provides a way to encode classification, ownership, retention, and permissible use restrictions directly with the data. Unlike visible labels, metadata can travel with data through systems and integrations, supporting enforcement even when users are unaware. Ownership metadata clarifies who is responsible for decisions and approvals related to the data. Retention metadata supports lifecycle management by indicating how long data should be kept and when it should be disposed of. Use restriction metadata defines boundaries on processing, sharing, or analysis. When metadata is used effectively, it turns classification into a machine-readable control rather than a purely human instruction.
Classification directly guides control selection, including encryption, access control, monitoring, and audit requirements. Higher sensitivity data may require stronger encryption, more restrictive access, and enhanced monitoring to detect misuse. Data with high integrity requirements may require validation, change controls, and reconciliation mechanisms. Data with high availability requirements may require redundancy, backups, and recovery testing. Aligning controls to classification ensures proportional protection rather than uniform over-engineering. This alignment also supports justification of security investment because controls can be tied to documented data value and risk. Data owners play a central role by approving classification and ensuring that handling requirements remain current and appropriate. Ownership clarifies accountability, preventing classification from becoming an abstract exercise without decision authority. Data owners understand business context, making them best positioned to assess impact and approve trade-offs. They also review classification when data use changes or when new risks emerge. Without active ownership, classification schemes degrade into outdated labels that no longer reflect reality. Strong ownership keeps classification aligned with both business need and risk posture. Documentation underpins the entire classification program by recording schemes, definitions, and escalation paths for disputes. Clear definitions prevent inconsistent interpretation across teams and systems. Documentation also explains how classification decisions are made and who has authority to resolve disagreements. Escalation paths matter because classification disputes often involve trade-offs between usability and protection. Recorded decisions create consistency and defensibility, especially during audits or incidents. Without documentation, classification becomes fragmented and difficult to enforce. In conclusion, the information lifecycle and data classification connect data value to practical protection rules that evolve over time. Lifecycle awareness ensures that protections adapt as data is created, used, shared, and ultimately disposed of. Classification translates abstract risk into actionable categories based on real harm. Handling rules, labeling, and metadata turn classification into consistent behavior across systems and teams. Ownership and documentation sustain accuracy and accountability as context changes. When lifecycle and classification work together, organizations protect information proportionally and deliberately rather than reactively. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.